Let's think of the forward reaction as a man throwing apples over his neighbor's wall. At first, only man A throws apples because man B does not have apples to throw. Eventually, man B starts to throw apples back. Think of man B throwing apples back as the reverse reaction. At first, man B is slow at throwing back, but he eventually speeds up. Man A and man B end up throwing apples at the same rate. Can you see that the number of apples on man A's side stays the same, and the number of apples on man B's side stays the same? We say they are in dynamic equilibrium. Chemists like to represent chemical equilibrium using two different graphs. The first graph is the rate of reaction against time, and the second is the concentration of reactants and products against time. Before we draw the graph together, let's take a look at the microscopic view of a reaction. In this closed container, we have molecules of A2 and molecules of B2 at the start of the reaction. The molecules gain energy and begin to move around faster and collide with each other. Some of these collisions are effective, and new molecules AB form. At first, there are many effective collisions, and the number of AB molecules increases quickly. But then, molecules of AB start colliding with each other to reform molecules of A2 and B2. The forward and reverse reactions continue to take place at the same time until the number of reactant molecules and product molecules stays constant and the rates of the reactions are equal. Right. With that microscopic view in mind, let's work out what the graph of reaction rate versus time will look like. We'll show the rate of forward reaction in red and the rate of the reverse reaction in blue. When the reaction starts, the forward reaction has a high reaction rate. There are many effective collisions and lots of product molecules form. But as the reactants form products, the rate slows down. At the same time, the reverse reaction starts from no reaction rate and increases. When the rate of the forward reaction and the rate of the reverse reaction are equal, chemical equilibrium is established.